Thanks, Alex. As we continue our path towards reducing complexity with Kubernetes, I'd like to introduce Anton Smith, formerly a product manager at Canonical and now the head of product at SpectroCloud, as he shows us easier ways to manage clusters while simultaneously unlocking the power of Charmhub and Charmed applications. Take it away, Anton.
Thank you, David. That was awesome. Okay, so hello, everyone. It's great to be here today, and it's always a pleasure to work together with Canonical. My name is Anton Smith, and I'm the head of product at SpectroCloud. Today, I'd like to talk about how we integrated Juju together with our product, Palette. Now, the cool thing about this was that we enable people to deploy and use this fantastic library of charms. But we also want to talk about Palette and Cluster API, which is a wonderful technology that is part of Kubernetes. To top it all off, I'm also going to tell you about how we pulled it all together into a GitOps-driven approach to deploy clusters at scale and enable them all to easily deploy Juju charms, also via GitOps. So in case you didn't get all of that, here's a briefer version. First, an intro to Palette. Second, how we integrated with Juju and used GitOps. And finally, a summary. So let's get started with Palette. We talked earlier about our belief that Kubernetes and containerization has not really reached its potential yet. The promise is really great with Gates: resilience, portability, productivity, scalability, efficiency, and agility. And the biggest thing I think that I love about Kubernetes is that we're enabling a cloud-native approach everywhere. At least the interface or API, once you've got your clusters up and running, is a beautiful thing. But the reality is that it is still hard for businesses to reap the full benefits. At SpectroCloud, we recently commissioned a research firm to conduct a study where probably the most interesting data point was that two-thirds of Kubernetes practitioners perceive the paradigm as a trade-off between flexibility and usability. In other words, they think you cannot have both with Kubernetes. And indeed, it's true. I mentioned before how wonderful it is once you have a cluster, but how can organizations deploy them and then manage them afterwards, keeping them in compliance for security updates, etc.? It becomes a really big challenge. The speed of change, diverse environments, etc. And that is our mission at SpectroCloud, is to change that with Palette. So just to reiterate, the challenge and what we learned from our survey is compounded by the number of clusters. 97% of our respondents had multiple clusters. Number of environments, 78% have multiple production environments, and 35% of them, interestingly, have already tried K8s at the edge. And the number of distros, with 89% of them having multiple distros. There's multiple distros of Kubernetes, not operating systems. And believe it or not, 8% of them had more than 10 distributions of Kubernetes. And on top of that, there's the number of applications and other integrations needed on those clusters. 79% had more than 5 layers, so more additional things deployed in their stacks. So our goal with Palette is to bring limitless scaling in terms of management, one-to-many, i.e. one platform for everything, consistency across environments, easy and complete management, so how we can manage those clusters and the stuff deployed on top of them, and total freedom as well on the stacks that people want to deploy. We allow people to form their own opinionated Kubernetes stack just the way that they want it, best of breed for their own purposes, and deploy and manage it at scale. Another recent development has been Cluster API, and I'm going to talk about that a bit today. As a standard for deploying Kubernetes clusters onto different substrates or different cloud environments, it's an amazing technology that really allows the clusters themselves to be abstracted and described using declarative techniques. It also covers the operating system, Kubernetes, CNI, and CSI layers of the stack, but it doesn't easily provide for end-to-end lifecycle management of the stack, and not the higher layers of the stack either. Now, interestingly, this is how SpectroCloud and Canonical started working together, because there is a cluster API provider for MAS, for deploying Kubernetes on bare metal. But let's interrupt this transmission. Here we have some little turtles. And let's take a simplistic tour of Cluster API, since it's such a core part of this technology and enabling all of this cool stuff that we're going to tell you about. Maybe you've seen these little turtles stacked on each other's backs before. So in the beginning, there was darkness. And then there was Kubernetes. And then there was Kubernetes the hard way. And I don't know how many of you have done Kubernetes the hard way, but it is a fairly interesting, lovely, painful thing to do that for me took quite a while to do it. And lots of copy pasting and lots of things going wrong. And well, we had to fix that somehow. So some great nights appeared. Bash, people and their scripts, kubespray, kubeadm, and any number of other things people developed in order to make deploying clusters easier. Now, Cluster API introduces something around using Kubernetes itself. So imagine that we had a declarative way of doing things like we have with Kubernetes. You say something, you write something, you say, this is the desired state I want to get to, and then Kubernetes will say, yes, sir, and it will go away and start to try to do that. What if we could actually do this with clusters? We could declare clusters themselves declaratively, the same way we declare other resources in Kubernetes. So let's declare all the things. The something that I mentioned before, but what is that? And well, that is Cluster API with a Kubernetes cluster. So a cluster, like a management cluster, that you use and that you work with to manage and deploy other clusters. And it makes perfect sense because this is exactly how Kubernetes itself works. So these mighty steeds appeared to help our knights, and this was the turtles, of course, which is Cluster API. So let's recap. We have a management cluster or a throwaway bootstrap cluster in some cases, and we use it to deploy clusters onto different substrates. Clusters need underlying resources. So Cluster API is modular, and it can support many different substrates, and these are called infrastructure providers, like Maz from Canonical for bare metal. There's one for AWS, there's one for VMware, etc. Okay, so we're back. So back to Palette. Now we spoke about Cluster API, and you see these little turtles down on the bottom left, and they're helping us manage the bottom layers. But what about the higher layers? Remember, 79% of our respondents had more than 5 layers. We have the substrates on the right-hand side, which is the public cloud, the bare metal, the Maz, etc., the VMware, and OpenStack. But we also need day 2 operations. So we need to standardize how, even though we're using Cluster API, how do we standardize things? How do we manage the Cluster API definitions themselves? It can quickly get out of hand. So Palette extends CAPI, Cluster API, to the full stack for existing clusters and for Edge. So what that means is we build this thing called a cluster profile. It's a beautiful, intuitive way to model a Kubernetes cluster, including add-ons. And using Palette with UI or programmatically, like with Terraform, you can create your own stack, complete with versions, operating system choices like Ubuntu, CNIs, CSIs, and any additional add-ons such as Service Mesh. And they're also completely flexible cluster profiles. So once defined, they can be used to essentially print out clusters at scale across any substrate using Cluster API. And it will then keep them in the desired state that you specified. So you create your own opinion about what your organization needs, and then you roll it out at scale to any substrate, Maz, VMware, public cloud, etc. And we can thank those little turtles again, because we have fully embraced what they offer, and we're building all of our functionality around those turtles. So we come to unified operations across clusters. So we need day 0 to day 2, right? So First, design. So cluster profiles helps you design what you want to do, build your opinion, both for infrastructure and add-on services. Deploy, so push that out onto multiple substrates, many clusters, and then manage. Day two, what happens after that? Update, security, auto healing, etc. So now that we've got all of that out of the way, let's talk about Palette and Juju. And the goals of what we did here were to unlock the Charmhub collection for usage with Palette, because it's a massive library and it has a number of very useful applications in it, including with data operations. And then we wanted to do it using GitOps to prove a super scalable approach and enable a true clusters as code methodology. And then we wanted to show you how easy it is to do using Palette. So the canonical Juju integration looks like this. I showed you the cluster profiles before. What we've done is that because we enable you to create your own layers as specifications inside Palette, we created one for Juju called OLM. Now, under the hood, it's actually going to do all the work using Juju. So we're enabling a translator in a way between our cluster profile and Juju. And then this will enable you to easily install any charms onto any of the clusters that have that OLM add-on defined. And this brings you consistent configuration and lifecycle management with cluster profiles. And it also works great with GitOps by design. And we're going to show you how. So I'm going to show you just some screenshots, but in 3 easy steps. We're going to first create an infrastructure cluster profile that includes the Juju OLM. We're going to create a Juju charm deployer add-on to enable deploying charms. And then we're going to create clusters at scale. Well, we're only going to create 1 or 2, but you could easily create thousands using this infrastructure and this add-on cluster profile together with GitOps. And here you can see a little screenshot of what it looked like in the Palette UI when I created this add-on profile using the UI. But we're also going to show you how to do it with code. So steps 1 and 2, this is literally all it is. We define an infrastructure profile specifying the base layers and Juju, as well as the cloud type. In this case, it's AWS, the operating system, Kubernetes distro, CNI, and CSI. And then, of course, Juju, which you can see in the far right box. But we also need to create an add-on profile, which is going to specify the charms. And this can be consumed when creating clusters. So we're creating the profiles that we need. And then in the next step, we're going to use those profiles to deploy. Now, you might notice that we also allow you to specify things like Juju relations. And we use this to specify a relation here between a database and an application like Mattermost. So to reiterate, we're creating with YAML code these add-on cluster profiles, and we're committing them into GitHub, which triggers some actions, which calls Palette using Terraform. And I think I mentioned Terraform before, but we have a lot of, we have great Terraform providers for Palette. And it instructs Palette, hey, these are the cluster profiles I would like to build. You could also do it in the UI. And what you get out of that is Palette ready to use those profiles, but nothing is happening just yet in terms of deploying the clusters. And then finally, step 3, cluster creation. All the hard work was done when we created the infrastructure and the add-on profiles. But now we need to create and commit a new cluster spec, referencing our profiles, and then we profit and win the game. So here you can see the name is AWS Canonical Demo. You can see which cloud account we're using, and you can see the profiles defined here, infra with AWS Infra and add-on with Juju Charms, which actually had, remember, the Mattermost and the database specified in it. And you can specify other things like AWS region or anything specific to a particular cloud provider, as well as your usual node groups, how many master nodes you want, how many worker nodes you want, etc. And you will then have this deployed if you push it, as if you commit it to the repo. So to reiterate, what you get from that is a cluster specification defined as YAML, as I showed you. You commit it to the repo. It uses Terraform again, talks to Palette, but this time Palette is actually going to take action and deploy many of these clusters, or as many as you like, all including Juju and all ready to have charms deployed to them. And if you want to add more charms afterwards, then you enable that by just doing some more commits to the repos for the existing clusters. And because of the declarative nature of all of this, those will then have those new applications installed in those clusters. So with that, you could create 1, 100, 10,000 clusters, all deployed and ready. So to summarize today, we've learned about Palette and cluster profiles and cluster API. We've seen how Charmhub can be unlocked by integrating Juju with Palette. We've demonstrated how we can easily build clusters at scale using a GitOps approach, including Juju. And we've got a full video demo here, as well as repos, if you would like to get into some more meat about this, rather than just me showing you slides. And this was thanks again to these little turtles that we love working with. Now, if you'd like to do some more reading, I really liked the CNCF webinar on Cluster API. You can see that on YouTube, as well as Getting Started with Cluster API Guide. And you can read about Palette and Juju at these links too. Now, finally, we have a free version of Palette, and we're always interested to hear from people wanting to try it out. Personally, I'm very excited to hear from people who want to give it a go. And maybe you'd like to try and follow along this Juju integration for yourself and try deploying some charms. And if you'd like to reach out to me to discuss more, here's my LinkedIn profile. And I think it's going to be very exciting to hear what people are going to do with all of this neat technology. So I'd like to hand it back to David. Thank you.